Hi friends, in this video we are going to talk about the joints in rigid pavement. Now what is the meaning of rigid pavement by the way? We are having two different types of pavement, right? Flexible as well as rigid, right? The flexible pavement can be also called as bituminous pavement because we are using bitumen and aggregates there. And the rigid pavement can be also called as concrete pavement or cement concrete pavement. Now, whenever we say cement concrete pavement, either it can be of PCC or it can be of RCC. What is the meaning of PCC? Plain cement concrete. Means there is no reinforcement there, just a plain concrete only. In RCC, as the name indicates, it will be reinforced with the steel bars. Right. So our rigid pavement can be either of PCC type or it is of RCC type. So whichever be the type, either PCC or RCC, the concept joint will be there for both type of rigid pavement. By the way, why we are calling it as concrete pavement or what is the meaning of this PCC, RCC and what? Whenever we construct a rigid pavement, the top layer, as you can see in this image also, the top layer will be a concrete slab. So this concrete slab can be either plain cement concrete slab or it may be of RCC, reinforced cement concrete slab. So below this only we will be having our subgrade soil. Okay, so this is nothing but the basic structure of a rigid pavement. So like this slab by slab we are going to construct our rigid pavement. In this particular image also you can see there is a small gap here, right? Why there is a gap? Because this is actually a particular slab and after constructing this slab we will be constructing the next slab like that. Are you able to see that in this particular image? I hope yes, right? So that particular gap or discontinuity is actually what we call as the joints in rigid pavement. So the word joint you might have already heard before, right? If you're having two different things, we can just joint them, right? Using nut and bolt and all. So this joint is not that joint, okay? Here joint indicates the discontinuity or gap in the rigid pavement. So how this gap is coming? Because we are going to construct our rigid pavement like slab by slab. Too many slabs we are going to arrange like we used to put tiles, no? Tiles or granite on the floor. Similarly like that, one tile, then next tile, then third tile, and sidewise also we'll be keeping, you know, exactly like that. So one slab we are keeping, then the next slab like that. So slab doesn't mean that like our, slab you might have seen footpath also, no? It's not like that, like a small slab. It will be like very long slab. It can be around 140 meters long and all. Okay, practically we may not be keeping that much. Around 45 meter like that maximum we will be keeping the length of one slab. And the width of the slab will be, what do you think? Look at the image. Width of that concrete slab will be how much? Very good. I hope you got it. What is that? Width of a particular lane on the road. Which means you can see in this image there are two lanes, right? This is one lane, this is second lane. So width of the first slab will be width of this road, width of the second slab will be width of the other road, like that. Understood? Now the discontinuities, too many discontinuities you are seeing here, no? So those discontinuities are in generally called as joints. Now you see which all discontinuities you are seeing. If I'm just taking a top view, just a simple representation like this, I hope you are able to understand. It means if the traffic direction, if I'm just drawing like this, let it be this a two-way road. It's not mandatory that it should be two-way road. It can be two-lane, one-way road also, right? Let it be. This is like this. We can see one discontinuity in the direction of this traffic direction, no? So there is a discontinuity here. I hope you're able to see that in the image. There is a discontinuity or there is a gap parallel to this traffic direction, or we can say in the direction of traffic. That is a particular joint which we can call as longitudinal joint. And you can also see another discontinuity in the perpendicular direction of traffic also. Right or not? Okay, so like this two different type of joints we are having. So in general, before coming to this particular diagram, I can say the joints are of two types. The joints which are in the longitudinal direction we can call as longitudinal joint, And there are some joints in the perpendicular direction also, no? So technically we can call it as transverse joints. These transverse joints are of three types. First one is expansion joint. You might have already heard about it. Expansion joint. The second type of transverse joint is contraction. Expansion, then contraction. Opposite to that, right? Contraction joint. The third, it is not that much important from competitive exam point of view, but still, construction joint. You should be knowing what it is. They can ask you for 1 mark and all. So from competitive exam point of view, the most important thing is this expansion joint, then this contraction joint. Okay, these two are the questions, I mean the topics which are generally being asked in the exams. And actually in this, under this longitudinal joint, we are going to study a concept called as tie bar. So this is the next concept which we need to study in detail. Okay, so let's see. In our session, we'll be discussing everything in detail. Let it be there as of now as an introductory portion. Now, I have taken a top view here, right? Simply a graphical representation. In this, can you please mark which will be the longitudinal the longitudinal joint? Suppose if this is the traffic direction, for example, then which will be the longitudinal joint? Yes, I hope you already got it. This is nothing but our longitudinal joint. No, everything. Okay, it's a continuous discontinuity, right? Anywhere you can mark it. Okay, anywhere. Let me just mark it here only. So this is nothing but our longitudinal joint. Right. Now, where is our transverse joint? This is the transverse joint. Now, perpendicular to the direction. But you see, the transverse joint I have just again subclassified into three groups: expansion, contraction, construction. Then where I'm going to mark all these three? At the end of a slab, we are going to get a discontinuity, no? Which I am already, marked in the image, right? So this discontinuity, where it is coming at the end of one particular slab, right? So this kind of transverse joint, we call it as expansion joint. Okay, and see at the end of this particular slab, the next discontinuity is coming. What is that? That is also expansion joint only, right? Like this, as the length of the road is increasing, the number of slabs also will be higher, and the expansion joints also will be there, obviously. Okay, that's it, simple. Now, where will be this contraction joint then? Where I'm going to mark the contraction joint? In between two expansion joints. Understood? So in between two expansion joints, we can mark the contraction joint. At what spacing it will be, that we need to calculate. Okay, what should be the spacing between these contraction joints? There is an equation for that. We'll be studying that also. Okay, so like this, we can mark it. So the gate examination and all, you don't have to draw and mark these things, but in case if they are giving some diagram and asking you to identify the type of joint, then you should know it. Okay, that's it. So all these blue color lines actually represents contraction joint. Okay, that's it. Now, where is the construction joint then? Construction joint generally don't use to mark on the image. That you will understand after some time when I'm just, when I'm explaining construction joint. We don't use to mark the construction joint here, only the longitudinal joint, expansion joints, and contraction joint we used to draw. Okay, so from here itself, we are getting so many points, very, very important points for 1 mark. See, the longitudinal direction, the longitudinal joint will be in the direction of traffic, right? Or I can say along the traffic direction. Whereas the expansion joint, contraction joint, as well as construction joint will be perpendicular to the traffic direction. So with respect to traffic direction only, we are just naming it as longitudinal and transverse. Transverse means what? Perpendicular, or I can say across, like that also we can say. Which means expansion joints are provided across the traffic direction or perpendicular to the traffic direction. Similarly, contraction as well as construction. Understood? Regarding tie bar, we are going to explain. As of now, let it be there. Okay. Once I am going into longitudinal joint, I am going to explain that. Okay, I hope you got a basic idea, right? Now let's see. In detail, we can explain one by one. The first thing, longitudinal joint. Okay, let me show you just some points first. Yeah, longitudinal joint. Now see, as the name indicates, it is in the direction of traffic, no? So where it is in the image, I hope you have already cracked it. Yes. So this discontinuity, hope you are able to see it, right? So that discontinuity is nothing but our longitudinal joint. Now, when that joint will be happening, when that gap will be happening, when we are keeping two slabs sidewise, right? Maybe one tile I'm keeping, another tile I'm just placing just sidewise on one side of the tile. Then there will be a gap no, in between them. Similarly, one concrete slab we are keeping, then the next slab sidewise. And there will be a gap no, that is called as longitudinal joint. Now look at the important points to be noted, very, very important for competitive exams. It is the joint in the direction of traffic. Yes, we have already explained that. Now, the longitudinal joint is provided when the road width exceeds 4.5 meter. Means what? If the width of this road is less than 4.5 meter, then we don't require a longitudinal joint. Means what? See, I already told you when this longitudinal joint is going to happen. Whenever two slabs are being kept sidewise, right? So if the road width, the required road width is less than 4.5 meter, we can just make the road using a single slab width or a single slab. That's it. Means what? It's going to be a single lane road like this. Understood? Are you seeing any sidewise gap or longitudinal gap? No, nothing, right? Which means this width will be how much? Definitely this width will be less than 4.5 meters. If the total width of the pavement is less than 4.5 meter, you can just construct one single slab. No need to divide into two pieces. Just one single slab. Suppose if the total width of the pavement is say 5 meter, for example, simply I'm telling, or let it be 5.5 meter, intermediate carriageway, you might have heard of minimum width of 5.5 meter. If not, let it be there, leave it as of now. So, for example, if it is 5 meter, then 2.5 meter, 2.5 meter, like that two slabs we are going to make. If the total width of the pavement is 6 meter, then 3 meter one slab, 3 meter other slab, sidewise. Understood? Then only what will happen? A sidewise longitudinal joint is going to create. Right? Joint in the sense discontinuity or gap. Understood? That's the meaning of that particular statement. That's what I have written as the third statement also. The longitudinal joint is not required on single lane road. Why? Single lane road means the minimum width will be how much? The minimum width of a single lane road is 3.75 meter. Means the width of the road can be 3.75, 3.8, 3.9, 4, anything. 4.5, above 4.5 meter, it may not be coming, right? That much width we are not going to provide for a single lane. In case if it is there, then it may be like an intermediate carriageway, or it can be a two-lane road. But for a two-lane road, minimum 7 meter width we require. So those are different topics. We are not going into that as of now. Okay. Now you see, once you are making a joint like this, or once you are keeping what I can say, a longitudinal gap like this, maybe if you are painting using some yellow paint or white paint above that, definitely it's going to act as a lane marking, no? Because it exactly divides the road into two pieces, or it is dividing the road into exactly two halves, right or not? So it acts as a lane marking. Understood? So these statements, either they can ask you directly for 1 mark or for an MSQ type of question, like which of the following statements are true with respect to a longitudinal joint, like that also they can ask. Okay. Now the last point, but very, very important point, the tie bars are provided across the longitudinal joint to hold the slabs in position together, which means what? Suppose if I'm having two different slabs, say like this, what will happen whenever the traffic, the vehicles are keep on moving and applying the brakes? There is a chance that this slab will be moving in the opposite direction. No, sidewise it may be moving, which means this gap may not be practically maintained. I don't know. Whenever the vehicles are moving, either this gap may be getting closed or the width of the gap can be again increased. right? The proper gap may not be getting maintained every time. To maintain that gap, what we need to do? You can just connect these two slabs. Very simple, using a tie bar or simply using a steel bar. That steel bar is actually called as a tie bar. Understood or not? Okay, so which means if I'm just taking that previous image, see here. How can we just mark a tie bar? The longitudinal joint, across the longitudinal joint, to keep these two slabs together like this, so many tie bars we are going to provide like this. Okay, we are not going to see that in the actual image. Why? Because these tie bars are not provided on the top surface. No, if the width of the slab is like this, maybe see somewhat at the mid depth only we are going to provide it. If you are having two different slabs, you want to connect it. How can we connect? At the mid depth, no? Obviously. So in the image from the top with the naked eye, we are not going to see tie bar. We'll see only that the gaps. That's it. Understood? So this is how we are going to mark it. So these are nothing but our tie bars. Okay. If you want to see the image of the real image of tie bar, look at here. So one lane you can see here. This is the traffic direction. The other lane we are going to, or the other slab we are going to place in this image. You are seeing the construction activity. The next slab is going to construct only. Okay. So before constructing, what we are going to do, we will be keeping some steel bars like this. You're able to see now at the middle depth. Sorry. At the middle depth, we are keeping some steel bars. So half of it is in the one slab. The next half will be on the other slab. It will be like that. Understood or not? Now tell me, what is the direction of the tie bar then? Longitudinal joints are in the direction of traffic, whereas tie bars are, yes, exactly, perpendicular. No, just go back. See, look at this image. This is the traffic direction, and a tie bar is placed across the traffic direction. Don't think that too many tie bars are there in the direction of traffic. It's not like that. Whenever we are telling the direction, we need to consider only single one particular tie bar. Then only we can say the direction of tie bar. Okay. So a tie bar, one single tie bar is perpendicular to the traffic direction, or we can say tie bar itself is across the longitudinal joint. No, tie bar is across or perpendicular, or we can say transverse, right? Transverse to the, or across the, okay, across the traffic direction. We can say either traffic direction or it is across the longitudinal joint. Like that also we can say, no, is across the longitudinal joint. Perpendicular, it's like a cross, no? Longitudinal joint is going like this, tie bar is like this. So it's like a cross, okay, across the direction. Understood? Now, very, very important. In RCC also you are going to study this concept. Whenever we are keeping one steel bar in concrete to make a bond between them, we have to ensure that a proper length of the steel bar has penetrated into the concrete. That is very, very important, which means, see, suppose if I'm just drawing the top view once again, I'm just exaggerating it. So this is one slab, okay, and this is another slab, okay, for example, just exaggerating that gap between them, okay. Now, to have a proper bond between them, whenever we are keeping, I'm just drawing one single tie bar, okay, let be, this is one single tie bar, just one only I'm showing, okay, fine. Now see, whenever we are keeping a tie bar like this, look at this portion. A portion got penetrated into the concrete. Now, we are drawing the top view. I hope you are understanding it. Look at this particular image. Some portion has gone into or penetrated into the concrete. Okay. So that particular length, what we call, it is called as development length. To develop a proper bond between the steel bar and the concrete, we should have a minimum penetration, or minimum, what I can say, that should be in the concrete for some particular minimum length. That is actually called as development length. The same thing you are going to study in RCC in detail, RCC subject. Okay, the same length will be here also, no? Development length, LD. Okay, plus there will be a small gap. of the longitudinal joint also. Gap of longitudinal joint. Now you see, what will be the total length of tie bar then? What will be the total length then? 2 times the development length, plus the gap of the longitudinal joint. Right or not? So this will be coming in the exam. What it is? This is the minimum length of tie bar. Minimum length of tie bar. Now sometimes they will be mentioning the gap in the question. Sometimes they may not mention. If they are not mentioning, then ignore it. Because compared to this development length, this gap will be practically very less. Okay. Compared to development length, this small gap, longitudinal joint gap, that will be very small. So sometimes we'll ignore it. We'll simply take 2 into development length only. But if they are giving in the question some value, say some 5 mm, 10 mm, 15 mm, like that, some small value they are giving, then add it. That's it, simple. Understood or not? Now in RCC, you will be studying the equation of this development length, but I am also telling it right now, okay, so that whenever you are studying RCC, your concept is going to be crystal clear. Also, we are going to do one question for this equation, okay? So this development length LD, it is actually pi into sigma ST divided by 4 tau BD. This is the equation. This equation, as I already told you, we'll study in detail in the RCC subject. But let me just explain what are the terms here. Pi stands for diameter of tie bar. We'll be using small diameter steel bars. No, mild steel bar this will be. So dia of the tie bar. Sigma stands for the stress. Nothing but the tensile stress. Tensile stress in the steel bar. And tau. Generally we use the symbol or notation tau BD. Symbol doesn't matter. Tau stands for bond strength or bond stress. Okay, between concrete and tie bar, or between tie bar and concrete. Okay. Now see why it is tensile stress? Because see, these two slabs are going apart, not trying to going apart. Now this steel bar will be trying to keep them in position. If I am the tie bar, and on both of my side there are two different slabs and they are going away, which means I'm going to get expanded. No, which means tensile stress is going to develop on me. That's why in the equation also tensile stress is coming. Okay. Now apart from this, 3 more equations you are going to study in RCC. Like for development length, actually 4 equations are there for development length. This is actually for I'm not going into details, but whenever you are studying RCC, you should not be getting confusion. So I'm just deviating from this particular topic. Let's listen here. There are 4 different equations for development length. Okay, 2 equations are for mild steel, and 2 equations are for HYSD steel bar. Okay, you might have already heard about HYSD, right? So 2 equations are for mild steel. One equation is mild steel under tension. Second equation, mild steel under compression. Similarly, HYSD bar under tension, HYSD bar under compression. Like this, 4 equations are there. In our case, we are using mild steel bar, and also I told you it will be under tension. So this is our case. For a tie bar, the case will be this first one. That is why we are using this particular equation. For other 3 cases, what all the changes are coming, that you will be studying in the RCC subject. Okay, the bond stress will be increased by 25%, 60%, like that. You will study there in detail. And right now I'm not going into that. Okay, otherwise the our concept will be getting deviated and we'll go somewhere else. So as of now, let it be there. So note down this equation. We are going to solve one question also. Okay, I'm not going to simply leave the equations here. We'll solve one question later. Okay, keep it there. So these are the things that you need to know about the longitudinal joint. Okay, so that's it, longitudinal. The second case or the second type of joint is transverse joint, right? 3 different joints are there under this transverse joint, or 3 different discontinuity or gaps are there which are in the perpendicular direction to the traffic, which are expansion, contraction, construction. So let's talk about expansion joint first, which is the most important thing. Okay, right? This is called as expansion joint. If I'm just taking the first real image, see here at the end of one slab, are you able to see one discontinuity here? Are you able to see that where it is actually? Yes, perpendicular to the traffic direction, right? Perpendicular to the traffic direction at the end of one particular slab, right or not? Yes, that is nothing but the expansion joint. Here I have just taken two different slabs just to show you the expansion joint. So in between, you can see a gap, no? So this gap is nothing but our expansion joint. Understood? Like that, so many expansion joints will be coming as the number of slabs increases. So this gap is throughout the width, no? One slab we are keeping, or one tile, next tile, right? Similarly, one slab, next slab. So throughout the thickness of the, or if I'm just keeping it as some h meter or h centimeter, whatever. Throughout that h, we are having the expansion joint. Right or not? Now, why we are giving that expansion joint? I've already written there, to allow the expansion of joints. Okay? Which means, sorry, not expansion of joints, expansion of slabs. Okay? To allow the expansion of slabs during a rise in temperature of the slab with respect to construction temperature. Means, suppose if you are not giving that particular gap, what will happen? See, in the railway track and all we used to give, no? You already know that. If you are having one slab, whenever the temperature is increasing due to sunlight, particularly in summer season and all, this will expand, no? So if you are not providing a particular gap there, what will happen? It will go and touch with the next slab and cracks will be developing, obviously. Right? To avoid that cracks, what we need to do? A small gap we are going to keep. Doesn't mean that too much of gap you can give, because if too much of gap is given, then what will happen? It will act like a gutter, no? Right? The vehicles will go and fall on that, obviously. So a small gap, very small gap. Okay, that is what is called as expansion joint. Understood? Now, whenever we are keeping that gap, there are few things which we need to keep in mind. Very, very important thing. See, if I'm just showing you that the thickness only, suppose if this is this is one slab. Hope you're able to understand that thickness only I'm just drawing here, okay? The next slab, okay. Now you're able to see the side view of expansion joint. Hope you're able to understand, which means this thickness is there, no? That is what you're seeing here. Got it now? Right. Now, this slab will be expanding to this side. This slab will be expanding to this side. Right or not? Can I just exaggerate that image? Okay, let me just take it down again. I'm just exaggerating it because I want to draw and show you something in detail. Just a second, guys. Okay, this is the end of one slab. This is the end of the other slab. Okay, let it be there as of now. Hope you are getting it. I'm not drawing to scale. Okay, don't think that the gap will be this much, then why the length of the slab is only this much. Don't think like that. Just focus on this particular area only. Okay. Now, one of the slab will be definitely expanding towards this side. The other slab will be expanding towards this side. Obviously, the other side also expansions will be there. Okay, that will be there. Just concentrate on this particular side only. Now, practically what we'll do, we will be filling this gap or discontinuity with some elastic material. Why? Otherwise, there will be a gap, a void space. So through the void space, water will be going inside the road and it will be reaching at the subgrid soil. Simple, right? Water should not go inside the pavement, no. I don't know. Proper drainage should be given. So we cannot simply keep that gap there like a void. What we need to do? We are going to fill it with some elastic material. Okay? We are going to fill it with some elastic material. But see, whenever we are keeping elastic material and the slab wants to expand, if elastic material is filled there, problem will be happening, no? No, that is why we are keeping elastic material. What is the meaning of elastic? Suppose if I am the elastic material, if I am there in the gap or that expansion joint, and the slabs are going to expand from both of my sides, what will happen? I will just contract. Right or not? The slabs are expanding, which means it is going to pull the elastic material. So if I am the elastic material, this is my initial thickness, or this is my initial width. What is going to happen to me? I will be getting contracted. Why? Because from both the sides, slabs are going to push me. Right or not? Right or not? So when the slab is pushing the elastic material from this side, and this slab is pushing the elastic material from the other side, obviously the elastic material will get contracted. But there is a particular property for this elastic material. This elastic material will be able to contract. It can contract maximum, contract up to maximum 50% of its width, or I can say thickness, whatever, of its width. What is the meaning of this? If I am having an elastic material of some 10 centimeter width, it can contract by 5 centimeter. If I am having an elastic material of 20 millimeter width, then it can contract by 10 millimeter. That's the meaning. Only 50% of it, it can contract. Understood? Which means, what should be the minimum gap I need to provide there? It will contract only 50%. Right or not? So suppose if the total expansion is, I'm just asking you something. If the total expansion is 10 millimeter, and if I'm just keeping only 10 millimeter gap there, will there be any problem? Of course. Why? Because the elastic material will not be able to contract by 10 mm. It will contract only by 5 mm. So whatever be the gap, half of that only it will contract. Then what to do? Whatever be the required expansion of the slab, 2 times of that particular value, we need to give the gap here to maintain that, or to compensate that 50%. Right or not? Which means, what should be the minimum gap here? Whatever be the required 10 mm, I have just taken as an example, no? Okay. What should be the minimum width or gap? Generally we use the word width. Okay. What should be the minimum width of expansion joint? What should be the minimum width of expansion joint? Whatever be the expansion of the slabs. Whatever be the expansion of the slab, 2 times of it we need to provide. Why? Because only 50% of the width will be getting contracted. If the expansion of slab is 10 mm, at least 20 mm width I need to give now. If I am giving 20 mm width, then only after 50%, the remaining is 10 mm. Yes, expansion is 10 mm, no issue. Understood or not? Okay, so this is one of the very, very important concept we need to note down. The minimum width of expansion joint is 2 times expansion of slab. So why this 2 times came? Because the elastic material can contract only by 50% of its width. If it can contract by 100%, 100% is not possible, no? It's like a water. Then it is okay. Whatever be the expansion of the slab, same thickness only or same width only, you need to provide. Now, since it is only 50%, what to do? Double of the expansion you need to provide there. Understood? So that this portion, see, after expanding, what will happen? This space will be occupied by the slab like this. Hope you're understanding. Now in that middle half portion, the elastic material will be contracted and occupied there. Understood? So look at here, this 2 arrow, this much indicates the total expansion. Now, what will be the total width then? It will be contracted, the remaining here, right? So 2 times the expansion of the slab. Hope you understood, right or not? So the next thing, how to calculate the expansion of the slab then? This is just example only. We can do questions later. How to calculate the expansion of slab? It is L alpha delta T. Hope we have already studied this equation before. L alpha delta T, which means if L is the length of the slab, the same length here also. And alpha is the coefficient of thermal expansion, and delta T is the change in temperature. L, the length of slab, alpha, coefficient of thermal expansion. In strength of materials, mechanics of solids, you will study this equation, right? The value generally, this is of concrete, okay? Coefficient of thermal expansion of concrete. And this is length of the slab. Generally, it will be in meters. And the coefficient of thermal expansion, generally for concrete, it will be around 1.2 into 10 raised to minus 5 per degree Celsius. Or I can say 12 into 10 raised to minus 6 per degree Celsius. Why I'm putting in per degree Celsius? This delta T is the change in temperature. That should be in degree Celsius. So per degree Celsius and degree Celsius, that will be getting cancelled, right? And the length, if you are substituting in meter, then expansion value also will be in meter. Understood, guys? Okay, so these points you need to keep in mind. Got it? Now, if you are, see one thing, whenever we are taking one particular slab, some portion will be expanding to one end, I mean towards the other side, and some portion will be expanding to the opposite side. So total is actually L alpha delta T. Okay, so what about one particular side? L alpha delta T by 2. But similarly, this slab is also there, na? That also will be having L alpha delta T by 2. So totally how much? L alpha delta T. Understood or not, guys? Okay. So from one side, we will be having L alpha delta T towards one side. Okay. From here to here, L alpha delta T by 2 will be there. Just a second. Yeah. Similarly, from the other side also, L alpha delta T by 2 will be there. Now, what will be the total expansion then? Half plus half, 1 full, right? So L alpha delta T. This will be the total expansion. Now, whatever be the total expansion, just multiply with 2. This is what? The required minimum width of the expansion joint. Understood? So this is one important point that you need to keep in mind. Now, whenever we are keeping such a gap, the problem is, see, look at this particular image. The problem is, we are actually breaking the entire pavement into 2, right? Or you're just breaking the pavement, that's it. Whenever you are breaking the pavement, see, just imagine a vehicle is traveling on this particular road. Okay, the load is right now acting here. Okay, will there be any load transfer from the first slab to the second slab? No, right? Or will there be any load sharing? Absolutely no. Why? Because they are not interconnected. If they were interconnected, then the load can be shared so that the effect of the load will be less. Right or not? Just imagine there is one person standing here and he has to carry a big load on his head. That's it. Too much. And there is another person standing here, but he is not helping him. Okay, so this is the first condition. And after some time, what will happen? The same load will be transferred to the second person's head. Okay, so at this point of time, only the first person is carrying all the load on his head. The second person is not helping him. Now, after some time, he is going to give this load to the second person, like this. Now, the first person will not help. Okay. Now, the third case, if I'm just telling, suppose instead of doing like this, if they were sharing those load, simply they were sharing those load, doesn't mean that they are going to put together like that. Just imagine, okay, if they were sharing those load, it is better for both of them now. Okay, so I am carrying the load for 1 hour, then I am giving it to you. You are carrying it for 1 hour or 1 minute. Is that better, or we both are carrying the load together for double time, 2 minutes? Which is better? Sharing, no? Because the stress on each slab will be less than, right or not? For that, what we are going to do, we'll be placing one steel bar between them. So they will be connected using a steel bar. I hope you are able to see that, right? So it will be connected using a steel bar. Maybe in the image, if I want to show, how can I draw that? How can I draw that? See, like this, I can draw. Understood? They are going to join together using some steel bars. So these are actually called as dowel bars. Dowel, dowel bars. So what do you mean by dowel bar? And can be also called as load transferring dowel bars, because they are used to transfer the load, no? So also can be used called as load transferring dowel bars. So one thing, at one side the dowel bars will be bonded, other side it will be free, which means, okay, if suppose if this is one slab, and just a second guys, this is the other slab. This is actually the thickness only, not the top view. Okay, just a second. Fine, the sidewise, okay, which means like this only we'll be having the double bar, no? Right. So generally we'll mark it like this. So one side it will be bonded. Generally we mark it like this. So one side it is bonded, and the other side it will be free. Like this only we used to mark. Okay. So this is actually called as the dowel bars or load transferring dowel bars. Now what is the direction of dowel bar then? Look at the image. What's the direction of dowel bar? Yes, exactly. In the direction of traffic. Right or not? So that also you just note down. Dowel bars in the direction of traffic. Understood? Now the tie bars were across the direction of traffic. Now dowel bars are in the direction of traffic. Understood? So that's all about the expansion joint. Now there is one important thing here. I told you the minimum width of expansion joint is 2 times the expansion of the slab. But you cannot give the gap too much, right? Because if you are giving too much gap, as I already told you before, there will be too much discomfort for the vehicles, right? The vehicle's tires will, fall into that gap. So what IRC says is the maximum width of the expansion joint can be only 25 millimeter. This is an important point. You cannot give a gap more than 25 mm, which means 2.5 centimeter. But suppose once you calculate this L alpha delta T, see what is our condition now? See, this is the equation now. Suppose if you calculate L alpha delta T into 2, and if you are getting around, see, 28 mm, then what to do? You cannot provide 28 mm, no, then what to do? Then again we'll calculate L alpha delta T into 2 is equal to 25 mm. This is the maximum value. Then what we need to do? This length we are going to reduce. Okay, so in case after calculating L alpha delta T into 2, if you are getting a value which is more than this maximum limit, which means more than 25 mm, then what to do? We'll just equate the value L alpha delta T into 2 is equal to 25 mm. Then we can check what will be or what can be the maximum length of the slab. So this is what I told you. Practically speaking, 140 meters we can give the length of the slab. But depends upon the change in temperature happening at that particular location. There is high chance that this value will be going beyond 25 mm. Okay, the width value. So that is why practically we are not going to give 140 meters and all for the slab length. Generally 40 meter, 45 meter, like that maximum. Means practical point of view I'm telling. Okay, so that also definitely depends upon how much change in temperature is happening at that particular location. From location to location it will have change, no? Okay, in some places too much difference in temperature will happen. In some places only a little bit change in temperature will happen, like that. Got it? So these are the points to be noted. We can do some question, then you are going to understand it clearly. Okay, before going into contraction joint, let me just take one question here so that the concept will be very clear now. Look at this. It's a previous 2-mark gate question. The question is like this. The width of expansion joint is 20 millimeter. Okay, the width is already given there. Now the laying temperature is 20 degrees Celsius, which means construction temperature. Maximum slab temperature in summer is 60 degrees Celsius. Okay, so from these two lines, what are things we got? The delta T, change in temperature, is given as, so 60 minus 20, 40 degrees Celsius. Okay. Now, in the third line, they have also given coefficient of thermal expansion, 10 into 10 raised to minus 6 per degree Celsius. See, I told you one value before, how much? 1.2 into 10 raised to minus 5 or 12 into 10 raised to minus 6. So by default, if they are not giving the value, take this, okay? Coefficient of thermal expansion of concrete. Okay, by default, if they are not giving, take this. But here it is given already 10 into like that. Then take the value which is given in the question only. Okay, right, that's it. Now, the width is already given as 20 mm. What we need to calculate is the spacing between expansion joint. What is the meaning of spacing between expansion joint? Look at this. What is the meaning of spacing between expansion joint? If I'm just taking the other image, look at this. What is the meaning of spacing between expansion joint? See, from one joint to the one expansion joint to the other expansion joint. What is this? This is approximately the length of the slab. No. Okay. Length of the, see, actually spacing means center to center, which means middle of first expansion joint to the middle of the next expansion joint. That is the actual concept. But that gap is very small. No. I told you already, maximum 25 mm gap. Okay, so from the middle of expansion joint to the middle of the next expansion joint means approximately it will be length of the slab only. Length of the slab itself will be around 40 meter, 45 meter. Then a small gap, some 10 mm here, 10 mm here, approximately 45 meter only now. That's what. So which means the spacing between expansion joint means length of the slab only. Okay, or approximately equal to, like that we can say. Which means we have an equation L alpha delta T into 2 is nothing but width of the expansion joint. Now this right side is actually given in the question, 20 millimeter. Unit is very, very important. Now L into 10 into 10 raised to minus 6 into 40. See, what is the unit? Degree Celsius and per degree Celsius. That will get cancels. So this much portion will not be having any unit. Now the length value we are going to get in which unit? In whichever unit you are substituting your width value, which we are substituted in millimeter right now. Okay, so the obtained value which we are going to calculate, which is 25,000, that also will be in which unit? In millimeter. We require in meter. How much meter it is? 25 meter. Option. Oh, sorry. This is B and this is C. Okay, so option C will be the final answer. Understood or not? Okay, so this is how we are going to calculate. See, they can give you, or they can ask you the question in the opposite way also. They can give you the spacing between expansion joint as 25 meter, or they can say that the length of the slab is 25 meter, and they can ask you what should be the minimum width of expansion joint required. Okay, I've already taken a question here just to understand that, you know, another way of asking question. Look at here. The length of the slab is given as 30 meter. Okay. Now the maximum change in temperature is given as 25 degrees Celsius. The minimum width of expansion joint. How to calculate that? Simple. Already we know the equation. The minimum width is equal to 2 times L alpha delta T. So L is 30 meter. Alpha is not given. So if not given, what to do? You need to take 1.2 into 10 raised to minus 5 or 12 into 10 raised to minus 6. Properly study, okay? Finally, don't put 1.2 into 10 raised to minus 6. Don't make that mistake, okay? Properly study. So L alpha, then delta T is 25 degrees Celsius. So this much portion, alpha into delta T, it is not having any unit. So the minimum width, if you are calculating like this, you are going to get it in meter. So once you are doing it, exactly 0.018 meter you are going to get. If you want to, see here I've not mentioned the unit, that will be dash mm. Then how to convert? Multiply with 1000. So it's going to be 18 That's it. Suppose if the value exceeds 25, then what to do? Your final answer we need to put as 25 mm. Okay, because that can be the maximum width of the expansion joint. So here it's comfortably less than 25. We can just write the less than 25 mm, hence okay. Otherwise, answer will become 25 mm only. Understood, guys? That's it. So that's all about the expansion joint. I hope you got the point. Right. Very important thing, the expansion joint is provided throughout the thickness, which means the entire slab is cut into two pieces like that. Like a Christmas cake or whatever cake, birthday cake or whatever. You're taking a cake and just cutting it throughout the cake like that. Expand. Every time we may not be cutting like that, no? Through the entire width, will you cut? Sometimes some small, at the half depth only we may be cutting, no? So it's not like that. Entire thickness we are cutting. Suppose if you are not cutting entire thickness, then it is actually called as contraction joint. Means, look at here. These are provided to allow the contraction of the slab. This is also typing mistake only. Contraction of the slab during a fall in temperature. Previous one was during a rise in temperature. During a rise in temperature only expansion will happen, no? Now during a fall in temperature, what we are going to do? What the slab will what will happen for the slab? There will be a contraction. So if we are not providing space for the slab to occupy, what will happen? Again, crack will generate. To avoid that, what we need to do? Again, some cracks, again, some discontinuity, some gap we need to provide. But you see, again, if you are cutting the slab, see somewhere here, again, if you are cutting the slab, what will happen? That will act as an expansion joint, no? Again, that is, being into two pieces, right? Then how we are going to give that? If you are giving throughout the width, if you are cutting throughout the width, this slab is again going into pieces. The single slab again will become like 2 or 3 pieces. So we cannot give like that. Then what to do? That's what I just told you. We are not going to give that, gap or cut throughout the width. We will be keeping, see, like this, like a groove. Okay, like the groove we are going to keep. Like whenever, if you used to make some fish fry and all at your home, to, what I can say, to make the masala exhale into the fish, what you'll do? You'll just put some lines now above the fish, right? Something like that. Or maybe on the concrete, we used to put some lines, no? To have a grip and all. So just imagine something like that. You are keeping some groove on the surface of the slab. Understood? I'm not good at drawing, but I hope this is clear. Right? Some groove we are keeping. Which means sidewise, if you are looking at it, how it will be? Suppose, just a second. Sidewise, if I'm just drawing it, see, sidewise it's already there. Still. Okay, just a second, guys. Suppose if this is our slab, then see like this, some grooves we'll be having like this. Understood? But let's see, there is one thing. Whenever we are cutting, that's another point. Let me tell that here itself. Whenever we are cutting, this cut will not be too much. It's a very small cut actually. Means this, previously I told you, throughout the depth or throughout the thickness of the pavement, we are cutting the expansion joint, no? This particular dimension. This will be, suppose if the entire thickness is h centimeter, hm or whatever, this will be only 25% to 33% of h, or I can say thickness. Understood? Or I can say this value will be how much? H by 4 to h by 3. H by 3 means 33.33, approximately 33. Right or not? So h by 4 to h by 3. Not even till the middle. Because at the middle portion, we need to keep another dowel bar. Below the expansion joint, we have kept dowel bar, no? So similarly here also, at the middle depth, we are going to give, just a second. At the middle depth, we are going to give another dowel bar. Just note down this. A dowel bar will be placed at h by 2, which means exactly at middle depth, 50%, then till 25 to 33%, or h by 4 to h by 3, we are going to make a groove. Understood? Similarly, so many grooves will be there. Now, how many grooves we are going to provide? That we are going to calculate now. Okay, there are some equations to calculate the spacing between these contraction joints. So this dowel bar will be kept at h by 2. Okay, and this groove depth will be h by 4 to everywhere. Okay, everywhere it is same. That's it. Now, suppose if I'm not giving this, what will happen? Let's say if I'm not giving this dowel bar, what will happen? This is actually not for load transferring. Below the expansion joint, we have provided the dowel bar for load transferring, right? Here it is not for load transferring. Then for what? Suppose if you are not giving that dowel bar, what is actually happening? Say, for example, this H was around 20 centimeter. Okay, let it be, for example. Okay. Now, once you are cutting 1/4 of that thickness, which means around 5 centimeter, you are cutting. H by 4 means 5 centimeter, no, according to this example. If you are cutting 5 centimeter, how much is remaining? Only 15 centimeter remaining, right? Only that much will be left. That thickness may not be sufficient for taking the load. See how we are going to decide this thickness? Based on the load coming on the road. Na? So we have designed already. In RCC and all, we'll design what should be the depth of the slab and all, what should be the width of the slab. So we have calculated some value and we are going to provide that value. No. So similarly here also, 20 centimeter thickness we have already designed. Now you are cutting some portion out of the 20 centimeter, for example, which means there is a high chance that cracks will be developing below that cut portion because insufficient depth is there or insufficient thickness of slab is there. Understand or not? Okay, so to avoid this crack, what we need to do, we are going to place a dowel bar. Now this dowel bar will take care of it. Now that weakened portion now has become strong. That's it. So if the dowel bar is not placed, if I'm just showing that, construction joint, the contraction joint only, if the dowel bar is not placed, what will happen? Just a second, small. What will happen? There will be cracks also. This is what is crack. Okay. Now if another image it is, if we are providing the dowel bar at the mid depth, then no crack will be generated. That's it. Okay, so these points we need to note. Clear or not? That's it. Understood, guys? Now, what should be the spacing between these grooves, or what should be the spacing between the contraction joint? That is the next point to be noted. Just note down spacing between contraction joint. Now, at the starting, I told you this slab can be either PCC or RCC, right? So for PCC slab, we are having one equation. And for RCC slab, we are having another equation. So whenever some questions are coming, you should properly read the question and understand whether the given rigid pavement or given pavement is of plain cement concrete type or reinforced cement concrete type. Accordingly, only the spacing equation we need to choose. So the spacing S is equal to 2 sigma CBC, sigma whatever, or 2 sigma C, like that also you can give, divided by gamma into F. That is the equation. I will explain what are the things. Where S is equal to 2 sigma ST AST divided by same equation, gamma C into F, but V into H also will come into picture. Now, I will explain what are each term. Okay, first you write the equation. Fine. Now, sigma CBC stands for the tensile stress in concrete. The tensile stress in concrete. Whereas here, sigma ST stands for the tensile stress in where it may be. It is reinforced, no, right now. Now the entire stress will be taken by the reinforcement. So here tensile stress of or tensile stress in steel. That's it. Previously in PCC slab, there is no steel, no reinforcement. So entire stress has to be taken by the concrete itself. Understood? So in the first equation of PCC, it will be of concrete. In the second equation, it will be of steel. So if you are closely observing, 2 into stress divided by gamma C into F it is enough. So here, only this much portion is coming extra. Okay, if it is RCC, this much portion is coming extra. Remaining things are same. In the first one, it is of concrete, stress in concrete. In the second one, it is stress in RCC. I mean, stress in steel. That's it. That is the only difference. Okay, fine. So like that, compare and study. Okay, otherwise we may forget it. Now, common term gamma C. What is gamma C? Unit weight of concrete. Unit weight of concrete in both places. Okay, it's common, right? Unit weight of concrete. Now, how much is unit weight of concrete? Mostly they will be giving in the question. Suppose if they are not giving, what value you need to take? For PCC, unit weight of concrete is taken as 2400 kilogram per meter cube. Whereas for RCC, it is taken as 2500 kilogram per meter cube because steel is also there, no? The unit weight will be increasing. Okay, so this is taken for in case of RCC slab and this is taken in case of PCC slab. So even though in the equation we write gamma C, based on the type of the slab we are using, the gamma C value also need to be changed. Okay, both places it is same. Okay, term is same, but the values are different. Now F, see suppose if they are giving some other value, like for example 25 kilonewton per meter cube, something like that if they are giving, then exact value, whatever given in the question, that you take. In the absence of data, take these values. Okay, F is nothing but the coefficient of friction. Coefficient of friction. In case if the value is not given, take F is equal to 1.5. In the geometry design and all, we used to study, no, not coefficient of lateral friction 0.15, right? Coefficient of lateral friction. In geometry design of road, we studied like this. Don't get confused with this. This is on the road between the wheel tires and the pavement and all. This is completely different. Okay, that is 0.15. This is 1.5. Easily you can remember that. Okay, now depends upon the type of the pavement. Choose the equation, do it. That's it. Okay, there is a condition or there is a specification as per IRC. This value should not be greater than 4.5 meter, which means maximum value is 4.5 meter. Or what we can say, this S should not be greater than 4.5 meter for PCC slab. Now for RCC slab, it may vary actually, depends upon the thickness of the pavement. Depends upon the thickness of the pavement, this maximum value will change. Maximum value of S, okay? If you are, suppose if you are using 15 centimeter thick slab, maximum 13 meter spacing is allowed. If you are using 20 centimeter thick slab, then maximum 14 meter width of spacing between contraction joint is allowed. If we are using 25 centimeter thick slab, then 17 meter spacing is allowed. Generally, you don't have to by heart all these things. This 4.5 meter you need to by heart. Also, this 14 meter you need to by heart. Because generally we use 20 centimeter for the thickness of the slab. What is the meaning of this 20 centimeter? This H. Okay, this is the thickness of the slab, right? Okay, that is the meaning of this thickness. Now, the width, the spacing can be maximum 14 meter. More than that, we don't use to give. That's it. Understood? Suppose after calculating, if you are getting, say, let it be, this is a 20 centimeter slab. Okay. This B and H. Okay, once again. These two terms, these extra terms we haven't defined now. Okay. So this AST is nothing but area of steel across the width, area of steel across the width of slab, and we can do a problem, you will understand it clearly. B stands for width of slab, and H stands for, we already know, that is thickness of slab. Okay, B stands for width of slab and H stands for thickness of slab. Okay, and suppose if you are getting, say H is say 20 centimeter, and you got a value, for example, some 16 meter and something, the final answer should be 14. That's it. It should not exceed the maximum limit. Understood? Similarly, for PCC, it should not exceed 4.5 meter. So these two things you need to keep in mind. Okay, guys. So for contraction joints, two things are important. One is the spacing between the contraction joint. The second thing is what is the size or dimension of that, cut. Okay. So h by 4 to h by 3, and the dowel bar is placed at the h by 2 depth or mid depth of or mid thickness of the slab. Understood? Right. Now we can do the question of yes. One second. So this question we have done. The second question also we have done. This is the third question. Okay, I've already taken one question for this mild steel bar. I mean the tie bar also. Okay, already we have explained the equation here. Okay, there is another question here. We can come to that. Before that, let's solve this question. Okay, the tensile stress developed in a PCC. What is the meaning of PCC? Plain cement concrete. Okay. Now finally they are asking the spacing between contraction joint. So whenever we say, whenever we see plain cement concrete, we have to remember the formula 2 sigma divided by unit weight into coefficient of friction. Right. Write the equation again and again. Okay. As many number of times you can write that many times. Okay. Otherwise, it's very difficult to remember all these formulae. Now that's equal to 2 into whether they have given any stress. Yes, in the question it is the how much? 0.56 unit kilogram per centimeter square. So write down along with the unit. Okay. Now divided by gamma C. Whether they have given? No, but we know the value 2400 kg per meter cube. Okay. Now F value whether it is given? Yes, 1.3. If not given, then take 1.5. But it is given in the question, then take whatever value given in the question. Now we can calculate it, but there is a challenge. What? This stress value is in kg per centimeter square, whereas this is in kg per meter cube. Now kilogram will get cancelled, but this centimeter square and meter cube, this should be in the same unit. Either you can convert this into kg per meter square, or you can convert this into kg per centimeter square. You can do whatever you want to do. Okay, ultimately the things will get cancelled, right or not? So once you're, suppose if I am interested in converting that 0.56 into kg per meter square, how much it will be? 0.56 kilogram per. Right now it is in centimeter square. So 1 centimeter is 10 raised to minus 2 meter. Right, centimeter square. Now how much it will be now? 0.56 divided by 10 raised to minus 4 kg per meter square. Right or not? So this conversion, a lot of students used to make mistake. So properly write, then you won't be getting any wrong value. Okay. So 2 into 0.56 divided by 10 raised to minus 4. It will go up. Right now it has become into kg per meter square. Divided by, it is PCC, so 2400 you need to take. So this is in kg per meter cube into 1.3. Now what will happen? Kg will get cancelled. Now meter square and this in this meter cube, 1 meter square will be going. It is down now. Now this meter will go up. The answer we are going to get in meter then. So once you are doing it, 3.589 meter you are going to get. It's comfortably less than 4.5 meter. Hence, okay, you need to write this step there. Okay, comfortably less than 4.5 meter. Hence, okay. Suppose if the calculated value is going beyond 4.5 meter, then the final answer should be 4.5. That's it. Got it, guys? Now, the next question. Look at the question. After this, we can do the question for tie bar also. Now, the width of the slab is given 4.2 meter, thickness is given 18 centimeter. Okay, so the dimension is given, right? So B is equal to 4.2 meter, H is 18 centimeter. Some random value they are giving. That's it. Okay. Generally 18 and all we may not be providing, 15, 20, 25 like that it may be. Whatever. Okay, something extra we may provide, 20 like that practically. Whatever. According to question, it is 18 centimeter. Now, it is reinforced with steel bars of 10 millimeter diameter. Okay, dia of reinforcement. It is 10 millimeter. Okay, that will be the with the spacing, center to center spacing, 260 mm. So this is not the spacing of the contraction joint. Okay, what is this space? What is this spacing? This is the reinforcement spacing. Okay, reinforced with the steel of 10 mm diameter, spaced at 260 mm center to center. In RCC, we are studying reinforcement and all. That's it. Now, the allowable tensile stress, sigma ST, is 1400 kilogram per centimeter square. Okay, let it be. Now, what will be the spacing between the contraction joint in meter round up to 1 decimal? Leave it there as of now. Okay, let me just calculate in meters, or see in whichever unit you want to calculate, you can do. Ultimately, we can just convert it. Okay. Now, we understood that it is reinforced with the steel bars, which means it is a, right? Reinforced with the steel bars means what it is? RCC slab. Simple. So spacing is equal to, just a second. Spacing is equal to equation. Write the equation as many times as possible. See 2 sigma ST divided by gamma C into F. Till here it is common, right? 2 sigma, whatever, sigma ST or CBC, whatever. 2 sigma divided by gamma C into F. Till here it is common, right? What is coming extra? AST divided by BH is coming extra. That you remember. Like that, you need to by heart the formula. Okay, guys. Now that's equal to 2 into 1400 unit is also important. Kg per centimeter square. AST is given or not? No, AST is not given. They have only given the diameter and the spacing. That's it. They have not given the area of steel value. Now, that we need to calculate. Let it be there as of now. Now, divided by how much is gamma C? Whether they have given? No. If they have not given, what to do then? We need to take the standard value. But it is RCC. So, if it is RCC, how much you need to take? 2500 you need to take. So kg per meter cube. Unit we can convert later into F value is given or not? Not given. If not given, what to do? There you go, 1.5. There is no unit. Now B into H. How much is B? 4.2 meter. How much is H? 18 centimeter. Now look at the values. Too much of unit changes, no? So we need to convert into same unit. But before converting into same units, we can just calculate this AST. Then we can come back. Okay, now how to calculate AST properly? See, it's not simply like the number of steel bars into the area of one steel bar like that. Yes, it is, but you see, either you can write like this, number of steel bars. Suppose if they are giving number of steel bar into area of single steel bar, like that you can write. But mostly they are not going to give you the number. If they are not giving the number, what to do? We are going to find the number. How to find the number of steel bars? Whatever we see across the width, like that we have written the equation now. Okay, where it is? See, look at the definition. Area of steel across the width. So in one width of the slab, what is the thickness? What is the area of the steel? That's what we are going to calculate. Now, width of slab divided by center to center spacing. So this is how we are going to calculate the number of steel bar into area of single bar. How much will be area of single type bar? Area of the single steel bar reinforcement. Pi by 4 into diameter square. Pi by 4 d square, no? Okay, pi by 4 d square. That's it. Simple. Cross-sectional area it is actually pi by 4 d square. Now you see width of slab is how much? 4.2 meter. Let's convert into mm because the spacing is given in mm, right? So 4.2 meter is nothing but 4.2 into 10 raised to 3 millimeter, 4.2 meter. That is equal to 260. I mean, the center to center spacing 260 mm into pi by 4 into 10 mm, no? 10 mm square. So this is what is nothing but AST. Now listen carefully. Once you are calculating this number of steel bars, you may be getting some, what I can say, a non-integer value. Okay, you may be getting a non-integer value. For example, how much it will be? 4,200 divided by 260. You are going to get 16.15, right? So 16.15 means there is no point. Either it should be 16 or 17 because it is a number, right? No need to round off it. Don't do it. Okay, this rounding is not required here because it is actually the concept is like how much actual area you required, like that. Okay, yes, it is correct that we cannot give 16.15 number of steel bars, either it should be 16 or 17. Yes, but what we used to do, we may be reducing the spacings and we may be giving 17 steel bar to compensate that. If you are simply giving 16, then obviously the sufficient area you are not going to provide. No, suppose if you want to give 17, then what is going to happen? The spacing is going to reduce, right? So maybe some extra steel you may have to provide. So these confusions or these problems will be happening. So practically we'll try to, what I can say, change the other properties or other dimensions or whatever. Then finally we'll be compensate this change. So while doing the question, what you need to do or what you should not do, you should not round off it to integer. Whatever you are getting, take as it is, which means once you are getting it, I mean, once you are calculating it, you're going to get some, like say 16.1538, something like that. No, take as it is. Okay, no need to round it off. Got it, guys? Into pi by 4 into 10 square or 100. So once you are calculating it separately, you are going to get 1268.72. In which unit it will be? This and this will get cancels. Now diameter square. Diameter 10 is in millimeter, no? So this is going to be mm square. That's it. So area we have calculated 1268.72. I hope now you understood how to calculate AST. Okay. So we have understood that using the help of a question. Got it. So now I need to substitute back to this particular equation. Now see, either you can convert all the things into meter terms or you can convert all the things into centimeter terms, whatever, whichever is convenient for you, you can, do like that. Let me just, okay, keep this 1400 there itself. So this is kg per centimeter square. Everything I'm just putting in kg and centimeters, okay? Anything you can put, no issue. Now, if this is in mm square, how much centimeter square it will be? 12.6872 centimeter square, right? Got it? Don't make mistake in the conversions, okay? So 12.6872. 6872. In which unit? Centimeter square. Now centimeter square and centimeter square will get cancels. In the numerator, I'm going to get only kilogram. Now 2500. It's in kilogram, but it's per meter cube. I want to change into centimeter cube. Right? In 1 meter cube, is 2500. Then in 1 centimeter cube, how much it will be? Divide by 10 raised to 6. Right? So I can write into, 10 raised to minus 6. Divide by 10 raised to 6. While going up, it will be into 10 raised to minus 6. So that much kilogram per centimeter cube. Okay. Now, into 1.5, which is F value, no unit. 4.2 meter, converting to centimeter, 420 centimeter. 18, that's it, centimeter only, no issue. Now let's check. Centimeter square get cancels. Kg cancels. Centimeter square. So centimeter square, centimeter cube will get cancels. So 1 centimeter will be there on the downside, right? In the denominator, downside of the denominator. So it will go up, right or not? So final answer, we are going to get it in meter. How much it will be? Once you are doing it, let me just calculate. So this is going to be, just a second guys. So actually when I have calculated, by mistake I have taken 2400. Just before taking the class I have taken, but by mistake I have taken 2400. That's why let me just calculate it using 2500. Okay, fine. Okay, so okay, you're going to get 1253.04, right or not? But this is going to be, oh sorry, it's not going to be in meter, it's going to be in centimeter. Sorry, I hope you have already noted that. Centimeter, right? So final answer is asked in meter, round off to 1 decimal. So we can just convert into meter. How much meter it will be? 12.53 meter. Approximately 12.5. That's it. Round off to 1 decimal. That's it. Okay. So if it is 18 centimeter slab, generally the spacing will be in between 13 and 14 meter, right? See, for example, where we have written that. See, look at here. 18 centimeter, no? For 15 centimeter slab, the maximum width is, or maximum spacing is 13 meter. For 20 centimeter, maximum spacing is 14 meter. Then 18 centimeter means definitely it's going to be in between 13 and 14. There is no point of, linear interpolation and all. Okay, there is nothing like that. Only these values are given in the IS code book. Okay, so however, our obtained value is less than 13. No? So no point of getting any confusion there. The final answer will be absolutely 12.5. That's it. Okay, so I hope you got the concept, guys. That's it. Here, especially note down how this area of steel or AST is calculated. Okay, cross-sectional area it is. Got it? That's it. Now at the end, we have to calculate the one, just one question for the tie bar also, so that you know the entire concept. We are not leaving any concept. For the entire concept, we are doing the questions. Okay. Now, what is the question? The required length of the tie bar. That's the question. Read it carefully. Now we know the required length of tie bar is what? 2 into development length plus the gap of or the width of expansion joint. That is the minimum length of tie bar, right? So that's going to be 2 times 5 into sigma st divided by 4 tau bd plus the width or gap of the expansion, gap of the longitudinal joint, not the expansion joint. Okay, so don't write it as, see, just cutting this and just putting it as 2. Don't do that, okay? That's not a good practice. We just write separately, okay? So 2 into, how much is 5? Diameter. How much it is? 5 mm, right? No, that could be one mistake you may be committing. Properly read the question. It is what? 5 mm radius, which means how much is dia? It's 10 mm. Okay, don't make any mistake. Generally, this is one point of making mistake. Okay, properly see. So 10 mm, this is in mm. Okay, now sigma st given as 220 megapascal. Unit conversion is to be done, but as of now, let it be there. Megapascal means, what is the meaning of megapascal? 1 megapascal means 1 Newton per mm square. Okay, so unit conversion we can see later. So 4 into tau bd. Tau bd is how much? 1.8 megapascal. See, now there is no point of unit conversion because the sigma st as well as tau bd both are given in megapascal. So this will get cancelled. Okay, that's it. Plus, if they are giving any gap, then add that. Otherwise, ignore, neglect it. Whether they have given, yes, they have given a small value, 12 mm. Okay. Suppose if that was not there in the question, then simply ignore it. Simple as it is. Okay. Now that's going to be equal to You can separately calculate it. Just again, 10 into 220 divided by 4 divided by 1.8. So this development length separately, if you are doing, it's going to be 305.55 mm, right? Plus 12. So totally how much it is going to be? It's going to be 611.11 mm plus 12. So this is what I told you. Compared to the total development length, 2 into LD. This gap is very small now. That is 611. This is 12. Small value. Okay. So in case if they are not giving, just ignore it. So total is going to be 623.11 mm. So approximately 0.6 meter. That's it. In which unit they are asking, by the way? Let me. Oh, in mm only they are asking. Then no need to change it. Leave it. Okay. Fine. In mm only they have asked. So 1623 round off to integer. So okay, just round off to integer 623. That's it. Now logically speaking, you need to round off to the next integer 624 mm. This is logically more correct, but 623 also they will be giving the answer. I mean they will be giving the mark. Why logically 624 is the right answer? Because minimum we should have 623.11 mm. Means 0.11 mm is also required. No? So 623 mm means what? 0.1 mm, 0.11 mm less. So that is not okay for us. Understood? We need to give at least 623.11 mm. So more than that only we need to provide. No? Minimum is this much. So 624 is logically correct, but whenever they are giving the answer key, they may be giving something like this 620 to 625. Like that, some range they may be giving. Doesn't matter. Understood or not? That's it. Okay, so these are the entire concepts of joints in rigid pavement. Okay, so I hope you got a clear idea regarding all the types of. Oh wait, we have not mentioned regarding construction joint, right? Sorry, just 1 minute. Okay, so construction joint means, look at here. Whenever we are constructing a rigid pavement, definitely 24 hours in a day we may not be working, right? 24 into 7 works can happen. Like if so many, 2-3 shifts are there. Some people will be working for 8 hours. The second set of people will be working for next shift. The third shift, another, set of people will be working for next 8 hours. Like that, if we are having daytime, nighttime shift and all, yes, continuously concrete laying work will be happening. But practically, suppose at the end of the work of one day, maybe in the evening, around 6 o'clock or 5 o'clock, if the concrete laying work is stopped for that particular day, then next day again they will come in the morning and start the work, restart the work. Okay. So there will be a discontinuity happening, no? Obviously. So from there only they need to start again. See, while whenever we are doing the renovation work of our home, okay, suppose there is already a building and you need to extend it, definitely there will be a chance of leakage there. Huh? Why? Because there is a discontinuity. Simple, right? At time of the renovation work, you might have already come across with such things, such problems, right? Why it is happening? Because of the discontinuity. We have not done it continuously. That's why. So here also, whenever we are stopping the work for a day or temporarily, maybe due to COVID and all, we have suspended all the works now. So like that, due to any reason, can be a flood, can be an earthquake. Maybe see, while this rigid pavement construction is going on, an earthquake is reported in the nearby city. So what will happen? Definitely, temporarily, the concrete work will be stopped because we are not sure whether the earthquake will happen again or not. No, once you are constructing everything, suddenly earthquake came, the entire thing will get cracked. No, it will get wasted. So we'll stop for some days, just check whether earthquake chance is there, what is the probability of coming earthquake again. All these things will be checking. So whatever be the reason, temporarily we are stopping the concrete laying work so that continuous work is not going to happen for any reason. The discontinuity will happen or not. Yes, discontinuity is what is mean by the term joint, right? Joint means discontinuity only. Okay, so why this discontinuity happen? Because of the construction work has stopped for some time. That's it. Okay. So such a discontinuity is called as construction joint. So if the concrete laying work is stopped for the day or suspended temporarily, okay, a discontinuity will be generated. Yes, that's what we have explained now. Now, such a discontinuity is termed as construction joint. Now, practically what we'll do, whenever we are constructing a particular slab, we will not be simply stopping the work. Okay, 5 o'clock. Okay, tata, bye bye. We'll not go like that. Okay, when we are going to stop a work, concrete work, whenever we are finishing one particular slab, then only we may be trying to stop the work. Which means, for example, if the slab length is around 40 meter, okay, totally 40 meter. At 5 o'clock or 6 o'clock, you are planning to stop the work, let it be. But at the 6 o'clock, we have reached around 39 meter. Okay, so your, working time is over now. But we are not going to leave it there and go. What will do? The next 1 meter also will construct. Whether it is 6 o'clock or 7 o'clock, we don't care. We'll try to make it till this end of one particular slab. We'll finish it. Then next day again, what we'll do? The next slab will start. Because however, there will be a gap will come now. We need a gap here already. Definitely we need a gap here. What is that? Expansion joint. Okay, so we are going to provide purposefully a joint there, purposefully a gap there. So what we'll do? We'll try to merge our construction joint with the expansion joint. Understood or not? We'll stop at the end of one particular slab only. So we are not going to mark anything extra on the top view or that image, because the construction joint will try to merge with the expansion joint. So that point you can write practically the contraction joints will try to merge with, not the contraction, the construction, okay? Practically, the construction joint will be tried to merge with which joint? Expansion joint. Understood? But every time it may not be possible, right? Oh, I have already written there. Practically, we'll try to merge the construction joint with the expansion joint. Already I have written there. You can just note down from here also. Both are same, okay? If not possible, then with the contraction joint. What is the meaning of that? This is what I told you. This is possible only if the slab length is about to over, right? Suppose at the end of one day, you have reached only like maybe 28 meter only you have reached at the end of one day. Remaining 12 meter, you may not be able to finish now. So what to do? Somewhere here we may require one contraction joint. Okay, then what to do? We'll construct till this contraction joint. Then we'll stop. Understood? If possible, we'll finish one slab, which means we'll reach till the expansion joint. If that is also not possible, too much time is required to reach at the expansion joint, then what to do? Then we'll stop the work at the contraction joint location. Okay, that is the meaning of this. Which means what? Stop the work. Stop the work at expansion joint. That's the meaning of this. And if not possible, then with contraction joint means what? Stop the work. Stop the work at the contraction joint. Hope it's clear, right? So that is the reason either the construction joint will be with the expansion joint or it will be with the contraction joint. That is the reason why here we are not drawing the construction joint. Suppose if I want to draw, then where I have to draw? Suppose if I have to draw it, let me use some other color to distinguish. Okay. Suppose if I have to draw, then either I have to draw, see, like this, on the expansion joint like this. Then we cannot distinguish between expansion and construction. No? That's it. We are not drawing. Otherwise, where I need to draw? Otherwise, on the contraction joint, I need to draw like this. Then also I cannot, distinguish between that. No. That's why we are not drawing any construction joint in the images, or what I can say, drawings generally. We will not be seeing construction joint there. Suppose if you want to draw, what you can do, either on the expansion joint you can draw, or on the contraction joint you can draw. That's it. Simple. Understood, guys? That's it. That's all about all the joints. I hope you got the concept clearly. So always remember about the expansion joint and contraction joint in detail. Also regarding tie bar and dowel bar. The location of these steel bars placed and the direction of the steel bars placed. All these things you need to keep in mind. Okay, so that's it. That's all about this topic. I hope you have enjoyed the class and I hope you have understood all the concepts. So we have explained the concept in that much detail. So if you have enjoyed the video, please show your love in the form of likes and comments. Please give your feedback in the comment section. Okay, so by then we'll meet with another topic. Bye.